Okay, guys, we're going to talk about something called the ACTS Rule and Quadrantal Angles. So, I have a list over here with different sine angles, and my calculator is currently set to degree mode. This is the only time that it's ever mattered. Now that we're in the trig section, if you're working in degree, be in degree mode. If you're working in radian, be in radian mode. So since you guys are more familiar with degree measurements at this time, I'm doing all this in degrees. But I do want you to know that, 0 degrees is the same as 0 radians. 45 degrees, well, that would be pi over 4. 90 degrees, that would be pi over 2, etc. But I want to start first by just getting some values here. And you're going to notice a pattern with the numbers that I used. First off, if you take your calculator and you punch in the sign of 0, you're going to get 0. Whoop, 0 for an answer. Now, if you punch in the sign of 45 degrees, you are going to get a super decimal. It's 0.7071. It's a big guy. I'm just going to call it 0.7-ish for now, okay? It's not so important the actual number at this point, but it will be shortly. But right now, I need a decimal. It's 0.7. I'm going to round it off. Then, the very next spot, when you punch it into your calculator, you'll do the sign of 90 degrees. You're going to get the answer 1. When you punch in sign of 135, go ahead, enter it in, and keep your display on. Don't clear out what you just did, and you'll see that you're going to see this 0.7 number again. Now, sign of 180. If you punch that guy into your calculator, you're going to also notice that guy is 0. Sine of 225. Now here is something interesting. Sine of 225 is that exact same huge big decimal, but this time it's negative 0.7. The sine of 270 degrees is negative 1. If you go ahead and punch in the sine of 315, you'll notice it is once again that big old number, negative 0.7 stuff. And then my last guy, sine of 360. Well, 360 is the same as 0 when you punch it into the calculator because those angles are what we call coterminal. So they both end in the same exact spot as each other. So that answer is 0. And I picked angles that are multiples of 45 just so I could get this done quicker. I could have picked 30s, 45s, 60s. I could have picked anything. But what I wanted you to see is this basic concept called the ACTS rule. The ACTS rule is something that we use to determine when a trigonometric function, and I'm using sine, so when is sine going to be positive, and when is sine going to be negative? Well, sine's positive all in quadrant 1. Now, I'm not going to go through cosine. I'm not going to go through tangent. I'm just going to say, hey, look at the pattern for sine, and then we'll discover it because we have to revisit the ACTS rule. We have to come back to it again. But I just want to get the basics out. So in quadrant 1, all trig functions are positive. That's what the A in the ACTS rule is talking about. All trig functions are positive. Now, the thing is, our coordinate system, we call, this guy over here is quadrant 1. Then we go counterclockwise. We call that quadrant 2. Counterclockwise, that's 3. Counterclockwise, that's 4. But when it comes to the ACTS rule, we go this way. So it spells out ACTS. Now this is the way it's written in our book. But I got to tell you, I borrowed a trick from my friend Miss Quigley on this. She always says, instead of ACTS rule, she says, all students take calculus. All students take calculus. But it doesn't spell the word ACTS then. It's ASTIC. So it sounds a little bit weirder. But what it tells me is, and this is why I picked on sine, if I go into quadrant 2, right here, this is an angle that would be in quadrant 2. If I drew a 135-degree angle, well, I start here at 0 degrees always. There's my 45. While I'm still in quadrant 1, all trig functions would be positive, but when I go into quadrant 2, there's a 135-degree angle. This guy right here, going to get my red pen, this guy right here would be called the terminal side of that angle. Well, the terminal side of that angle is in quadrant 2. Well, what do you notice about sine in quadrant 2? Well, I notice, and I got to get rid of some of this stuff, but I notice when I get into this quadrant that sine is still a positive value. So the ACTS rule helps me find out where different functions are positive. Now you'll notice sine is positive in quadrant 1 and in quadrant 2. But once I go into quadrant 3, a 225-degree angle, well, that would put me over here for sine. And you'll notice sine is negative. But guess what the T stands for? The T stands for tangent. When I'm in quadrant 3, the tangent is the only positive trig value. And then guess what C stands for? In quadrant 4, I have the letter C. That means if I were to punch in numbers that lie in quadrant 4, cosine's the only guy who's going to be positive. So the ACTS rule just says, in quadrant 1, no matter what trig function you're using, sine, cosine, tangent, cotangent, secant, whatever function you're trying to use, in quadrant 1, all answers will turn out to be positive, like this guy turned out to be positive in quadrant 1. But when I travel to quadrant 2, the only guy that remains positive will be sine. If I were to punch in right now on my calculator, what is the cosine of 135 degrees? If I were to do that, I'm going to grab my calc. I would get cosine of 135. Oh my gosh, I got that weird angle again. But guess what? This guy is now negative 0.7, all that stuff. So the ACTS rule is our guide, our quick way to remember where the different trig functions are going to be positive. So once I get into quadrant 3 here with like this 225-degree angle, before I even punch it in on my calculator, I know that it's going to be a negative answer. Just like a 315-degree angle will be a negative answer. But you'll also notice, excuse me, that we have some special guys. 0 degrees, I got 0 for an answer. 90 degrees, I got 1 for an answer. 180, I got 0 for an answer. At 270 degrees, I got negative 1 for an answer. And back to 360, all the way back around full circle, I'm back to 0. Now, these guys, these special angles, are the ones that we call quadrantal. Quadrantal angles are the ones that lie on our axes. So if you tried to draw a right triangle that has a 0-degree angle in it, guess what? You can't. Quadrantal angles are the ones that you cannot draw a right triangle for. A 0-degree angle, well, you're not going to have much of a triangle there. But a 90-degree angle, you can't draw a right triangle with two 90-degree angles in it either. If the angle that we're talking about lands on one of our axes, that's 90 more, that would bring me up to what, 180? That would land on one of our axes. I go 90 more here, I'd end up at 270. That's on our axes, and then grand total all the way around 360, I'd be right back onto this x-axis here. These guys are called quadrantal. Now, there's good news and bad news about quadrantal angles. Quadrantal angles, you can't draw a triangle for them to find their sine or their cosine or whatever, but you can use your calculator for any of them. Now, the thing is in the book, it's going to say, do not use a calculator. And that's fine. I'm going to show you the way you can do it without a calculator, and it's not hard to do. But in the meantime, I want you to understand that if you're finding the sine, cosine, or tangent of something, there is a pattern. And I wrote it down up here. Let me show you. I wanted to give you guys a blast from the past. Hey, look, that's my old whiteboard from the classroom. That's what it would look like. That's what it would look like if we were in the classroom. And this just says Quadrantal Facts. So all quadrantal angles are the ones that are 0, 90, 180, 270, or 360, or any multiple of that. I know that a 720-degree angle will land me at the same spot as a 0-degree angle. So any of these angles, there's a pattern to them. So sine, I just did this one on the calculator for you, but here's a little chart to keep in mind. Notice, when I try to take the cosine of 0 on my calculator, it'll say 1. If I tried to take the cosine of 90, it'll say 0. And etc., etc., etc. So these are the quadrantal angles here. And I did the big three. I did sine, cosine, and tangent for you. And you'll notice, tangent of 90, it'll tell you on your calculator, undefined. Tangent of 270, your calculator is going to give you an error message. Tangent 270. It'll say error domain. Now, you don't have to worry so much about that. We're going to be expanding on that concept just for the time being. What I want you to realize is there can be some asymptotes for some of these graphs, and wherever there are asymptotes, you will find undefined answers. So take a look down here on this chart I made. Where sine is 0, cosecant will be undefined. So we're not going to do it in this lesson. We're not. It's in the next one. But we're not going to be saying what is the cosecant of 180 degrees. We're not today. But what would that really mean? It would mean, hey, 1 over the sine of 180. And we see in the chart the sine of 180 is 0. So if I tried to punch in 1 divided by sine 180, go ahead, see what you get. 1 divided by the sine of 180 degrees, your calculator is going to say undefined. Why? My calculator says you're trying to divide by 0. Now, the error messages you receive from your calculator, they have to do with what these functions actually look like when they're graphed. So right now, this one just says, hey, if you're trying to do this, you're dividing by 0. What do we call it? We just say, hey, this is undefined. That's what we're going to use to answer these questions right now. And you'll see that when you do the problems in the book, that you'll look up the answer and it'll say undefined sometimes. That's always a good answer for this type of situation. So once again, where cosine is 0, if cosine is 0, that means secant is going to be undefined. So this information down here. And where tangent is 0, that means cotangent is undefined. This little chart right here, if you took a picture of this with your phone, when you go through the next section with me, you're going to find a couple answers where you go, wait a minute, my calculator won't do this, or there's no way to draw a right triangle and find the tangent of this or whatever. You can use this little chart instead of punching everything in on your calculator. And if you do get confused by what your calculator is saying, then refer back to this chart. That's why I made it. And in the classroom, this is what I would show you, so that if you get stuck and you're like, why does my calculator say err? These are the guys that are going to do that to you. So let's talk a little bit about this. Not all angles are quadrantal, but the ones that are, well, 0 degrees, 90, 180, 270, 360. Remember, these also have radian equivalents. So sometimes in the book, they'll make us work in radian. Sometimes they'll make us work in degree. So all of these guys here are the radian version of quadrantal angles. I ran out of room. Of quadrantal angles also. Now, the one thing that I haven't mentioned yet, but I'm going to have to do it in the next video, has to do with negative angles. So let me just quickly draw a little thing here. If I have a coordinate system, and I start here at 0 degrees, and they tell me to draw a negative 90-degree angle, that would put me right on the line here. Well, that's going to give me the same exact result as a 270-degree angle. Or if they said, even boldly, what if we want you to have a negative 270-degree angle? Well, wouldn't that be the same thing as a positive 90-degree angle? You'd still end up here. So keep in mind, we don't just measure things in positive degrees. Sometimes we use negative degrees. But it doesn't mean these guys are not quadrantal. If you land on either the x positive side, the y positive side, the x negative side, or the y negative side, you have found yourself in quadrantal town. So quadrantal angles could be positive or negative degree measurements, or they could be positive or negative radian measurements. So let me just ask you a quick question and see what you think. If I asked you to punch in the sine of a negative 2 pi angle, we've already talked about radians. So sine of a negative 2 pi angle. Well, if I want to punch this into my calculator and just let my calculator do it, I better make sure I'm in the right mode. But what I'm trying to get at is, eventually, when you start playing around with this, you're going to get to the point where you don't even look at your calculator for something like that. You'll just say, oh, well, that's the same thing as making one full revolution, ending up back here at 0. And guess what? The sine of 0 degrees is the exact same thing as the sine of 0 radians. It's 0. All right, so just to recap quickly. if you're a multiple of 90 degrees, you land on one of the one of the axes points, it's a quadrantal angle. Your calculator knows all the quadrantal angles. It also knows when to tell you it's undefined, but it has a funny way of saying it. That's why the chart is helpful. Then, the other thing that I need you to get from this is sometimes the trig functions we are dealing with are positive, and sometimes they are negative. Like here, this one sine 2, that's negative. That guy's negative. Well, the ACTS rule tells us where things should be positive and where they should be negative. That is the job of the ACTS rule. And once again, some people don't like to go clockwise. If you go counterclockwise, Miss Quigley says all students take calculus. That's how she teaches the ACTS rule. Okay, we will use the ACTS rule and we will use the quadrantal stuff in our next 2 lessons. This is just information that you need to know. And if you really remember, if you're ever confused, ask for help. Okay, thank you very much. Let's stop this one.